Find the area bounded by the given curves. We've got three curves. Y equals 3x plus 4. We have x squared, and we have negative x plus 2. So I'm going to graph it first so I get an idea of what's going on. Okay, so let me move this over a little bit. Now, I'm going to do a scale here of, this is going to be -1 this way, and this is going to be a +1 that way. And then I'm going to count up 1, 2, 3, 4, like that. Okay. Now, to graph a line, y equal mx plus b. B is where I put my first dot at the 4, and then my slope is up 3 over 1. That's at 3 right there. So that's the same as going down 3, left 1. And then I'm going to connect the dots. Oh, excuse me. Okay. I'll do my best to connect these dots. All right. So that's this line right here, y equal 3x plus 4. Okay. X squared, parabola, centered at the origin, up 1 over 1, up 3 over 1, up 5 over 1. However, my units are off. So up 1 over 1 is right here. Up over 1, up 3 is going to be like way the heck up here. Okay. So up 1 over 1, up 1 over 3. So you need to be aware of what your scale is. Okay. If you're having trouble finding dots, what do? You plug in points, right? If I plug in 0 squared, I get 0. 1 squared, I get 1. 2 squared, I get 4. So I have 1, 1, 2, 4. Negative 1, 1, right? Negative 2, 4. So on. Okay, and then this last one here, y equal negative x plus 2. So m, -1 slope. Start at 2, that's my b. So I'm going down 1 over 1, just like this. Down 1 over 1. Okay. So where do all these cross? Well, the bounded region ends up being this region right here. What a mess. Okay. There's a lot of stuff going on here. So this equation is y equal negative x plus 2. This equation is y equal x squared. And then this equation is y equal 3x plus 4. All right, so 3 main boundaries here. Okay, so I need to find the area of this bounded region. All right. I am going to use X easy. So I'm going to cut with delta X rectangles. Now I draw in an arbitrary rectangle here. What I notice, okay, let me zoom in a little bit. I have one top and one bottom all the way up until this point right here. And then what happens? I get a new top, but I have the same bottom. So I'm going to have how many integrals here? I'm going to have two different integrals. So one integral that's going to find area on this right side here. And then another integral that's going to find area on this left side here. Okay? So what I need to do is I need to figure out what that boundary point is right there. So I need to figure out where these two intersect. Well, how do I do that? I set them equal to each other. What do I set equal to each other? Y equal 3x plus 4 and y equal negative x plus 2. So y equal 3x plus 4 and y equal negative x plus 2. I'm going to replace y with this here. So I get negative x plus 2 equals 3x plus 4. Add x, I get 2 equals 4x plus 4. Subtract 4 from both sides, I get negative 2 equals 4x. So that means x is equal to negative 1/2. Does that make sense? It looks like this would be a negative 1/2 tick mark there. So, and in fact it is. Now, we've drawn the picture perfectly, so we know where those cross and where those cross. But say we hadn't, we would need to figure out what those values are. So let's do that. So we got x equal to negative 1/2 for that piece. Let's find it for this one over here. How would I do that? Well, I need that equation and then the x squared one. Okay, so let's do it. So let me shrink this down because I don't need that anymore. I got the answer. So I have y equals 3x plus 4 and then y equals x squared. So I'm going to replace y with x squared. So I have x squared plus equals 3x plus 4. We'll move everything over to one side. So x squared minus 3x minus 4 equals 0. If I factor, I have x minus 4 and then x plus 1. That adds to negative 3. So this gets me x equals 4 and this gets me x equals negative 1. So x equals negative 1 here. And x equal to 4 would be like if we continue drawing this picture and then eventually the parabola meets up with that line like way up here at x equal to 4. Do we want that? That value is not needed. So this is why you need to draw the picture so you know which information you're gathering. You don't just pick, oh, I'm going to set it up as those two right there, right? So we don't need that one. Okay, so now we've got that one. Let's do the last intersection. So that's this line and this curve here. So same thing. I'm going to set up. I have y equals minus x plus 2 and then y equal x squared. So x squared equals negative x plus 2. Move everything to one side. And then a factor plus 2 minus 1. Adds 2 and minus 1 is a positive 1 there. That's what we wanted to add to. Equal to 0 for factoring. If you're having trouble, if you forget how to factor, go back to a college algebra video on how to factor. I do a pretty good video explaining that if you're a little rusty on factoring. Factoring, you gotta know how to factor in math just like you gotta know the alphabet to read. Okay? Very vital. So x equals -2 and x equals 1. So -2, that would be this intersection over here, which is extraneous for our purposes. What we are concerned about is this intersect right here, which is x equal to 1. So that x equal to 1. So if you hadn't drawn a perfectly lined up picture like I did, then you may not have had that information. And to get that information, you set the appropriate boundary equations equal to each other. Okay? So just to make sure we're clear on this, if I'm looking for this intersection, I find where this curve and this curve cross, set them equal to each other. If I'm looking for this intersection, I find where that curve and that curve cross. And if I'm looking for this intersection, I find where this curve and this curve cross. And so you look at those corresponding equations, set them equal to each other, and you find these x values. Okay? So now we know our bounds, we can set up our integral. So my integral, I've got two integrals. I've got this blue one first. So integral left to right. So I start summing at -1, and I sum rectangles all the way to -1/2. And what are they? Top minus bottom. The top is 3x plus 4 minus the bottom. The bottom equation is x squared. Okay? Dx. Now the second part is the integral from where? Where do I start summing? I start summing my rectangles from -1/2. And I sum all the way to x equal to 1. Okay, what is the top? The top is -x plus 2 minus the bottom. What is the bottom? X squared dx. And now all it amounts to do once you've got this set up, so I've got my arbitrary rectangles drawn in there. I set up the integral, I find the antiderivative, and then I evaluate. Okay, so I'm going to let you do the algebra here. When I work through the math, I end up getting 7/12 for the first part. And then for the second part, I get 9/4. And so whenever I add all of that together, I get 17/6. Okay, so I want you to try to see if you can do this part here. So find the antiderivative, then do f of b minus f of a. It's a lot of algebra and then arithmetic, but those should be the answers that you get to. If you're having trouble getting that answer, go back to the previous 50-minute video and watch that again to see those steps. Okay, we're building up, getting better and better at this. Okay, so this is more of a concept video. Now I want to do one more of x easy, and then we'll do a y easy problem so you get to see what that looks like. And so I've got a function, it's a trig function, sine x, and another function, another trig function, cosine of 2x. Okay, and I want to go, I want to find the area bounded, and I have x equal -pi/2 to x equal pi/6. Okay. So this will be found by setting sine x equal to cosine of 2x. Now what do you know about cosine of 2x? Well, cosine of 2x has an identity, cosine squared x minus sine squared x. The problem here with this 2x versus the x is they have different arguments. We want to have the same argument, so I use the identity to get them to have all the same argument here, all argument of x. Okay? Now I want to get everything in terms of sine, so I'm going to replace this with 1 minus sine squared x. Okay. So this gets me sine x equals 1 minus 2 sine squared x. I'm going to add 2 sine squared x, and I'm going to subtract 1. I'm going to do that to both sides. And I get 2 sine squared x plus sine x minus 1 equal to 0. Okay? So if you're having trouble seeing how to factor this, then what you can do is you can treat it like 2x squared plus x minus 1. And how would you factor that? That would be 2x, and then I'd have an x, and I think 1 would be a minus, 1 would be a plus. I think this is the plus, and I think this is the minus. This is the guess and check method. The AC method would be pretty slick and for sure getting the right answer here. And so, but remember, this is just representing that thing, right? So really, this can be replaced with sine squared x, and this is sine x, and then this can be replaced with sine x and sine x, right? So now you've just factored a function, a quadratic in terms of sine x, all right? So you're just replacing, it's just your, think of it kind of like your blob, right? And then what is the blob? The blob is sine x, okay? So it's 2 sine x minus 1 times sine x plus 1. And if I solve, I get 2 sine x minus 1 equal to 0, and sine x plus 1 equals 0. So I get sine x equals 1/2, and sine x equals -1. Now, when I think about a unit circle, sine x equals 1/2 when I'm at an angle of pi over 6. Okay. It equals -1 whenever I'm at an angle of negative pi over 2. So that's where these values come into play here. Okay, so when we graph this, we shall see the graph kind of looks like this. Sine x, remember it comes to the origin. Okay, so this is f of x right here. And then cosine of 2x, remember the cosine function starts at 0, right? And it works its way down. But at 2x, it's working its way down at twice the speed, okay? So it's going to make its way through the cycle in the same speed that it takes sine to do it double speed, okay? So in pi units, right, it's already made one full cycle, all right? All right, so what I'm looking for is this point. Sorry, let me redraw that. Okay. So negative pi over 2. Okay. And then here, where it intersects, is pi over 6. That's where these values come into play. So I want to know what's the area of this region in here. All right. So if you were to graph this, how would you graph this in your calculator? So graphing calculator, skip for now, skip anyways. Okay. So I have sine x. Okay, y2, I'm going to do red for y3. This is going to be cosine 2x. Enter, and we'll plot it. So you can see here, so we're crossing. I'm going to screenshot this. So you see here is that x equals pi over 6, and here is that x equals negative pi over 2, and we're finding this area between these two curves here. So that top curve is cosine 2x, and the bottom curve is sine of x, right? So you can see how that worked out. Okay, boom. Kind of cool. Okay, so what are we going to do? What are we going to do from here? Well, we need to evaluate the integral. Okay, so how do we do that? Well, I set it up. Integral from negative pi over 2 to pi over 6. Top minus bottom, dx. So top is cosine 2x minus bottom sine x dx. Okay. And for this one here, cosine 2x, so I'm going to break this up into two integrals. Minus pi over 2, pi over 6. We'll delete this. And I'm going to do cosine 2x dx, and then plus integral negative pi over 2 to pi over 6, negative sine x dx. Okay, and so what does this get me? U substitution here. U equals 2x, du equals 2 dx. I only see a dx, so I don't see a 2 dx. So what I need to do is I need to divide both sides by 2. Okay, so this is going to get me 1/2, and I'm going to drop my bounds for now while I'm doing the definite integral. I'm going to do an indefinite. And so that's going to be cosine u, or replace u from the 2x, du. Okay, and then here I can integrate negative sine is cosine. Okay, evaluated from minus pi over 2 to pi over 6. Now the integral of cosine is sine u. Okay, 1/2 sine u, but remember u is equal to 2x. So I'm going to replace u with 2x. Just like that. And it's now I can put my bounds back in. Negative pi over 2 to pi over 6. So if I want, I can combine this as a one integral. Integrate. So I have 1/2 sine of 2x plus cosine of x from negative pi over 2 to pi over 6. So I'll plug this in. I get 1/2 sine of 2 pi over 6 plus cosine pi over 6 minus 1/2 sine 2 negative pi over 2 plus cosine negative pi over 2. Okay, so this in here is going to reduce to pi over 3. And then this in here is going to reduce to negative pi. So that's going to be what? 1/2 times sine of pi over 3 is square root 3 over 2. If I get one of these accidentally wrong, please forgive me. The second one, cosine of pi over 6 is square root 3 over 2. Minus, and then 1/2 times sine of, always draw the unit circle, negative pi goes this way, so sine is 0. And then plus cosine of negative pi over 2, that's an x equal to 0 there. So that second piece is 0. All right, so that all goes to 0. So what do I have? Looks like I have, I could factor a square root of 3 out of that, and I have 1/2 plus 1. So that's like 2 over 2. So that's 3 over 2 times square root 3 over 2. So that's 3 square root 3 over 4. Okay? And if there's any justice in the world, that's going to be like 1.299. Let's check it out. 3 times 3 square rooted. Okay. Divided by 4. 1.299. Yay, we got it right. Okay. So approximately 1.299. So the exact answer right there. Okay? So a little bit of a trigonometry review from pre-cal that I was throwing in there for you. That way, if you see something with trig, you're not freaking out. You go back to your trig identities that you learned in pre-cal. You're going to have to get a reference sheet or something if you don't have those memorized. Okay, so those could pop up at any point.